In this lesson, we will determine the inverse of a matrix. So the inverse of a matrix, we already talked about exactly what that is, but we haven't talked about how to find it if we are not given the inverse. So one way to do that is to write your matrix in the form of whatever your matrix is, and then whatever the identity matrix is. So they have to be a square matrix. So if it's a 2 by 2, the identity matrix is 1, 0, 0, 1. If it's a 3 by 3, remember the identity matrix has 1s in the diagonals and everything else is zeros. Then we're going to perform row operations to get it in the form so that the left side is now the identity matrix and the right side is not going to be A, it's going to be something else. That something else will be the inverse of matrix A. Let's try one together. First thing I'm going to do is just write this exactly as it is on the left side. And on the right side, I'm writing the identity matrix. So my focus, just as it was before, is to turn the left side into the identity matrix, so the same way I was doing this before. So for instance, my first step might be to take 2 times R1 and add it to R3 to get a new R3, which means R1 and R2 will remain the same. And so I'm one step closer. Again, remember that I am trying to get 1 here, and then a 1 here, and then a 1 here. So it would make more sense to swap these two, since this is already 1, 0, 1, which is what I want. So we'll call that R2. We'll flip-flop with R3, so interchanging rows. Everything else remains the same. Now remember, in my third row, I want this to also be a 0. So I'm going to take R2 plus R3 to give me my new R3. Everything else remains the same. And now the only thing really missing is that I need this to also be a 0. So I'm going to take a negative R3 plus R1 to be my new R1. Negative R3 plus R1 to be my new R1. Keep in mind that whatever I'm doing over here, I'm also doing to this side. Okay, I just realized before I did this step that this is actually a negative 1. It was from the beginning. I forgot to write the negative 1, which means I'm taking a positive R3 plus an R1 because that will make that value 0. So now that I've done all of my row operations, you can see on the left side I have the identity matrix 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, which means that B is the matrix 3, 1, 1, 2, 0, 1, 2, 1, 1, which means that's the inverse of A. So this is the inverse matrix. Go ahead and do that for matrix A. Find the inverse if it is possible using that same strategy. So first thing I'm going to do is I'm going to make my new R2 to be 2 times R1 plus R2. That's going to be my new R2 because I want this to be a 0 and I don't want to deal with fractions till I'm ready to do that. So 2 times that plus 4 gives me 0. I suppose I should rewrite the rest of this. So 2 times R1 plus R2 gives me 0. 2 times 5 is 10 plus negative 10 is 0. 2 times 3 is 6 plus negative 6 is 0. And then I see that I get 0, 0, 0. This gives me 2 and 1 and 0. So because I ended up with this situation, I know that this is a singular matrix, which basically means that no, I cannot have a no inverse. I cannot have an inverse on this. It doesn't work. So it only works if doing this, going through that process works to find the inverse. Now, if you have a 2 by 2 matrix, and the normal 2 by 2 matrix we'll just say is A, B, C, D, we can actually use a formula instead of using that method. And the formula is easier because it's frankly a lot less work. So what we end up doing is to find the inverse, we have 1 over A times D minus B times C. So in essence, we're multiplying the diagonals and subtracting them. And then notice what happens here is the first diagonal we switch positions, and the second diagonal we switch signs. So let's find the inverse using that method. So I'm going to take A inverse, which is going to be 1 over 29 times 2 minus 19 times 3 multiplied by the matrix. So I'm going to take these two and switch positions, 2 and 29. And I'm going to take these two and change signs, so negative 3 and negative 19. So let's do a little bit of simplification. So that's 1 over 58 minus 57 times all of that. Of course, 58 minus 57 is 1, so it's 1 over 1. So the inverse of A is 1 times all of that, which is 2, negative 3, negative 19, 29. Now we could have certainly found this using the other method that we used with the 3 by 3 matrices, but this way is much easier if you have a 2 by 2. Go ahead and use that formula to find the inverse of this matrix as well. So again, my original matrix, this is A, B, C, and D. So the inverse matrix, if it exists, is 1 over negative 4 times negative 2 minus 3 times 0. The first diagonal, we switch spots. The second diagonal, we switch signs. That leaves me with negative 4 times negative 2, which is 8, minus 0. So that's 8. So I have 1/8 times all of this, which means my inverse matrix is a little bit ugly, but that's okay. 1/8 times negative 2 is negative 2/8, or negative 1/4. 1/8 times 0 is 0. 1/8 times negative 3 is negative 3/8. And 1/8 times negative 4 is negative 4/8, or negative 1/2. So that is my inverse matrix.